Hey there, in this video we're going to look at how we can store our calculations in variables to use later. So we did see a variable already in the math package. We stored the value of pi in a variable called math.pi. We can make our own variables, and we do that with an equal sign. So if I want to store a value in the variable x, I'll just do x equals whatever I want to store. Let's go 42. So now the value 42 is stored in x. The way you should think about statements like this, any statement like this, is assign the name, whatever is on the left, to whatever is on the right. So Python assigns names to objects, and I use the term object as a very generic word for things like numbers, or strings of letters, or functions, or Python modules, or really anything in Python can be assigned to a variable. This is different than some programming languages. And a number of programming languages, you're not allowed to have a variable equal to a function. That's okay in Python. You can do that. So remember, that's what these sort of statements always mean. This is not going to do algebra for you. So I can't say 2 times x equals x plus 1. That is not a meaningful statement in Python, even if you could algebraically solve this and figure out that that means x equals 1. When I try to run it, it's going to be mad. Because of what I typed out here. It's going to be, don't really think of this so much as equals in the algebra sense, more as assigned to. So variables come in a few different types. So I have x there is an integer type. You can see the help right here is telling me that x is an integer type. We can make floating point types. So that means types that have a non-zero decimal place, 12.3. And so we should, there we go, tells us that it's floating point type. And there's a third numerical type called complex, which is a complex number. So that's represented by writing the real part plus the imaginary part. We append a j for the imaginary part. You might be used to I for the complex number in Python, and most engineering fields, it's a j instead. So 4.5j represents our complex number. And we can add these things together freely. Python will upgrade whatever number it needs to make this work. So if I try to add an integer to a floating point number, that is just fine in Python. It will convert the x, the 42 here, to 42.0 so that it can add it to the floating point number 12.3. Same thing with the complex. We can add a complex to an integer or a floating point number, and Python will know what to do. You can explicitly check the type without using context help by using the function type. So I can ask for the type of x and it will tell me it's an integer. You usually are not going to be doing this in any program you'd write, but just be aware that it's possible. If you ever find yourself trying to use this in a program, like I really need to check what type x is and do this or that depending on the type, you've probably written your program wrong. That kind of temptation tends to show up if you've programmed in other languages where type is much more strictly enforced than it is in Python. Python's what's called a weakly typed language. That means you can change the type of a variable. You don't have to be really explicit about what it is. In other languages, you have to be really specific. So if I was writing C code, I would have to type something like integer x equals 42 and tell the computer x is an integer and only an integer. Whereas in Python, I don't say that. I just say x is 42, and I can change what x is. Because what I'm saying here is assign the name x to 12 point, well, I already used that number. Let's make it 12.5. And what will happen here is x is now just directed to another thing. So let's come back to that name and object idea. Let's type out some code here. I'm going to clean things up for us so there's not too much to look at. Okay, so let's say let's x equals 1, and then let's let y equal x. Okay, and see what's going to happen here when I print out x and y. So I can do, to print out x and to print out y, I could use 2 print statements, one on each line, or I can use a comma in here. And what this will do is it's going to print x, leave a space, the comma says leave a space, and then print a y. So what we see here is both are equal to 1. First statement assigns the name x to the value 1. Second statement assigns the name y to whatever value x refers to. Okay, so let's make a picture of what just happened there. So we have names and we have objects. Got the first line, x equals 1, says take the name x and assign that name to the object 1. And then Python is going to reserve some memory in your computer to store the value 1. The second line, y equals x, says create the name y and assign it to whatever x represents. So they're going to, in this case, both refer to the value 1, both x and y. Now, question for you. What do you think would happen if I now run the code y equals 2? Will that affect x? So let's look at what Python does. So now I type out y equals 2. And I print x and y. Well, I see x has not been affected. The statement y equals 2 says assign the name y to the value 2. It doesn't say anything about x. It doesn't say anything about the value y used to be. So to add to our picture, what this does is it creates a value 2 in the computer's memory. The old reference is just gone, and now y refers to 2. And I haven't done anything to x. Okay, so our model here is names referring to objects. The last thing I want to look at is forcing conversions from one type to another. There's usually no need for this. The big exception being if you're trying to read information out of a file on your computer. Okay, so let's say I've got, let's make some new names because I've been using X, Y, and Z a lot. Let's say A here. A is equal to 3. And I want to make A be a floating point number. So somewhere earlier in my computer program, A got assigned the value 3, which happens to be an integer value. And I want to make it a floating point value. I can force that by using the function float. Float will convert anything it can into a floating point number. Similar functions to this are int and complex, to turn anything into an integer or to turn anything into a complex value. So if I do this and print A and B, I'll get the integer 3 is what A is, and then B gets to be a floating point version of 3. The thing I think is really cool about these and really handy when you're reading information out of a file is they also work with strings. So if I'm reading data out of a file, I'm going to get values that are actually strings. So like if I have a data file that includes 1.3, it's not the number 1.3 that enters my computer, but the symbol 1, dot, and 3. But I can change that into a floating point value by wrapping it with the float function. And that'll give me the floating point value 1.3. Sadly, this is not quite smart enough to read English, so I can't say give me the integer value of the word 3. It doesn't understand that, but it will give me the integer value of the symbol 3. You can also use this to transfer down to simpler types. So if I had the value 3.7 and I ask for the integer version of 3.7, what it's going to do is it's going to throw away the decimal place and give me the value 3. So let's wrap it up for this video. We've learned that in Python, a variable is a name that's attached to an object. You can freely change what these names refer to. Python is weakly typed, meaning that the names are not fixed to any specific type of variable. The three main numerical variables we have are integers, floating point numbers, and complex numbers, and we can force conversion by using functions named int, float, and complex.